Hey mathematicians, here are your notes for lesson 8.6. We're going to be solving rational equations and inequalities, and this is your day 1 video. So a rational equation contains one or more rational expressions. Remember, that's just fancy words for fractions. You can succeed using a couple different methods. I have a preference, but I suggest that you use whatever works for you. The first method uses a common denominator, and we multiply each side by that common denominator to essentially get rid of the fractions very early on. The second method allows you to get a common denominator and add the fractions, so you only have one to deal with, and then we can cross multiply and solve. I suggest for this first one, you do it both ways, and then after that, kind of decide which method works better for you. So let's jump into it. I have x divided by 2 plus 2x divided by 3 equals 7. Now, my first method, I would take this and I would say, well, what is the common denominator of 2 and 3? It happens to be 6, so what I'm going to do is I'm going to multiply by 6 on the left and 6 on the right. Now, 6 times x divided by 2 would be 3x, and I've gotten rid of one fraction. 6 times 2x is 12x divided by 3. I get 4x, got rid of another fraction. And then 7 times 6, I end up getting 42. And from there, I just simplify to get x equals 6. The other method says multiply the fractions individually. If I have x divided by 2 and 2x divided by 3, I need to multiply the first one by 3 over 3 and multiply the second one by 2 over 2. Once I do that, I get 3x over 6 plus 4x over 6 equals 7. I get 7x over 6 equals 7. I'm going to write it as a fraction, and then I'm just going to cross multiply. 7x times 1 is 7x, 6 times 7 is 42, and x equals 6. Again, this method is easier if you are okay with fractions, you are good at cross multiplication. This one is better if you like to get rid of the fractions early. Unfortunately, not all of them are only going to have fractions on one side. Some of them will have fractions on both. In this case, we are going to have to find the common denominator for all of them. So in this case, the common denominator would obviously be x plus 1. This one has a 5, this one has a 5 and a 2. I would say that the common denominator to multiply these by would be 10x plus 1. Because the 10 will get rid of this 10, it'll get rid of that 5, and it'll get rid of the x plus 1. Now I'm going to multiply that into all of my terms. Okay. So when I do that to the first term, the 10s are going to cancel. I'm left with 9 times x plus 1. When I multiply it to the second term, the x plus 1s cancel. I'm left with 10 times 2, which is 20. When I do it to the third, 10 times 2 is 20, and 20 divided by 5 is 4. So then I have 4 outside of x plus 1. I love this method because even though it takes a little bit more thinking up front, once you get rid of the fractions, significantly easier. From here, we're just going to simplify. 4x plus 4. Let's go ahead and get all of the variables on one side, all the numbers on the other. So the 9 and 20, 29, get it to the other side. 4x comes over. We get 5x equals negative 25. X equals negative 5. I do want to note with this one that if we had gotten a variable answer, it's important to note that you do have an excluded value. Because if we plug in x equals negative 1, we're going to break that fraction. We do not want that. Moving on to the next one. I always say factor first so you can see just exactly what you need to multiply by. This one cannot be factored, but over here we could rewrite 4r plus 2 as 2 times 2r plus 1. This now shows me that I only need to multiply this one by 2 and 3, and this one by 2 times 2r plus 1, not by the 4r plus 2. I'm going to do this one individually so that you can see what it looks like to see that second method, and then I'm going to go back to the other one. So 2r plus 1 is going to need a 2 and a 3, so we're going to multiply that first one by 6. So 6 outside of r plus 2 equals. Okay. R is going to need the 2 and the 2r plus 1. I could just multiply by 4r. So r outside of 4r plus 2 plus 3. It's got 4r plus 2. It's already got the 2 and the r plus 1, so I'm going to do a 3. So 3 times 3. Now, because we did it individually, these are all still over that common denominator of 6 2r plus 1. 6 outside of 2r plus 1. Now that I have that, I can go ahead and cross simplify. I'm going to rewrite this without all of the fractions, so it's a little bit easier to look at. So we're essentially going to have 6r plus 12 equals, oh, this one needed a 2. There we go. Fixed it. All right, 2r outside of 2r plus 1. I already had it in the 4r plus 2, but I got distracted. That happens. And then plus 9. And from there, we're going to simplify just like we did at the end of the last one. Let's go ahead and distribute. 4r squared plus 2r plus 9. Subtract things over. 4r squared minus 4r minus 3. And when we get to this point, we are going to have to bring back that factoring. I'm going to use the figure it out method. Notice that with that 4 in front, you're probably going to want to use the x method. But again, completely up to you. 2r times 2r is 4r squared. 3 and 1 multiply to 3. Negative makes this negative 6, positive 2, so I get that negative 4r in the middle. And when I solve, I get r equals 3/2 and minus 1/2. But again, let's go back to it. Let's make sure that that doesn't cause any problems. Our original excluded values here were r equals negative 1/2. If we solve either one of those, we're going to get that. So because that's an excluded value, even though we got it as an answer at the end of the day, that does not work because it is an excluded value. All right, let's take a look at this next one. Now, I've had a lot of students ask, well, can you find the excluded values first and then kind of come back to them? Yeah, absolutely. Let's do that here. X cannot be equal to 2 or negative 4. If we do that now, we can just easier look back later. But again, totally up to you. I am going to factor this just to make sure that there's no other excluded values that I'm ignoring. However, when I do that, I find out that it's x plus 4 and x minus 2, and those excluded values were already taken care of over here. So, what denominator would cancel out, because I'm going to go back to method 1, what would cancel out x plus 4, x minus 2, x minus 2, and x plus 4? Great, great thing. It's literally just going to be x plus 4 and x minus 2. The trick is to realize that it doesn't cancel everything when you do this. So when you multiply these to the first term, the x plus 4 cancels, the x minus 2 cancels, you're just left with 3x. But when you distribute it to this one, only the x minus 2 cancels, and you get 1 times x plus 4. On the last one, only the x plus 4 cancels. You're left with the x minus 2. So you have to say plus x times x minus 2. The nice thing is, again, even though that's a little hard, now we can just simplify. X plus 4 plus x squared minus 2x. Let's bring that 3x over. And we get x squared. There's an x, negative 2x, that's negative x, minus another 3x would be negative 4x. That 4 doesn't combine with anybody, so we just get plus 4. Gonna factor it again. I get x minus 2, x minus 2. And I get that x equals 2. Except, if I go back to the excluded values, my answer is one of my excluded values. If this happens, this means that there's no viable answer that could possibly put in to get a solution for this problem because it's included in the excluded values. All right, last up. It's going to be a long one, but we've got this. Stay with me. As soon as my program refocuses. Maybe it won't. Maybe we won't have to do the last. Oh, there it went. Out of luck. All right. So what would cancel out a denominator of x minus 2 and a denominator of x plus 1? Well, if we want to cancel it out, we got to multiply it. So we're going to multiply by both of them. When I multiply into the first, the x minus 2 cancels. I'm left with 4 outside of x plus 1. When I go to the second, the x minus 1 cancels, and I'm left with the x minus 2. So I have negative x plus 6, x minus 2. And unfortunately, when I multiply to that far-sided 1, neither one of them cancels. So I have x plus 1, x minus 2. On the bright side, I don't have any fractions. On the not so bright side, I have a lot of multiplication to do. Let's get to it. 4x plus 4. I'm going to FOIL this first and then distribute that in. So x squared, negative 2x plus 6x would be 4x. 6 times negative 2 would be negative 12. X squared, negative 2x plus 1x would be negative x, and minus 2. And here, we're just going to simplify, and then I'm going to move these to the other side. If I try to explain while I write, sometimes I make mistakes, so give me just a minute to write all this out. It's like walking and chewing gum. Not everyone is a professional. All right, now I want to get this to 0, and I want to simplify this down a ton because this is making me stressy. So I'm going to get all the x squareds over. I'm going to get that x over by adding it, and then I'm going to add 2 over. When I do this, I end up getting 2x squared minus x minus 18 equals 0. Unfortunately, it does not matter if you use the x method or the figure it out. This does not factor. And when something does not factor, that's right. It's everybody's favorite, the quadratic formula. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. I will save you some time. I suggest that you do this problem on your own. Go ahead and pause the video, take a minute. But when you get through simplifying, we end up getting that, I'll put it down here actually, x equals 1 plus or minus the square root of 145 divided by 4. That is not one of the excluded values, which would have been positive 2 or negative 1. So this ends up being our final answer. You will notice down at the bottom here, you can use a graphing calculator to check, but it doesn't give answers in root form. So if you want to learn how to do this, I would suggest you come ask one of us. We can easily help you find where that's at in your calculator. As usual, if you have any questions, please don't hesitate to let me know.